Congratulations, you made it. 9.10 carboxylic acids, esters, and amides. Or amides. I'll never learn how to pronounce that word. Let's go ahead and get started. We're going to cover them in order: carboxylic acids, then esters, and then amides, and then a little kind of mixing of the two at the very end. But nothing crazy. This is your last one. I hope you've been taking great notes. Just continue doing this. Your test should either be tomorrow or the next day. So I wish you the best of luck. Remember, ask me any questions if you have any, all right? Here we go. Carboxylic acid. Notice all three of these, by the way, have a carbonyl group with them, okay? It's all what's attached to that carbonyl group that makes it one of these three things. If it's a hydroxyl group connected to the carbonyl group, it's called a carboxylic acid. If it is just an O with a C, so this is kind of looks like an ether here, this is considered to be a carboxylic ester. So an ether is just COC, and an ester is the carbonyl group OC. So that's kind of what it looks like. And an amide is the carbonyl group hooked to an amine group. So look at that. That AM is amine or amide. So that should be a nice tip-off that we have right there. So let's go through, and we're going to go through each one separately. This one shouldn't take too long. We'll see how it goes. Let's see. So here's some common carboxylic acids. This one right here is called ethanoic acid. I'll come back and show you that. Let me show you why this is actually this is also called acetic acid, or the main ingredient vinegar. Let me show you why it's called an acetic acid. First of all, it's called ethanoic because, of course, it does have this carboxylic acid. But this subgroup right here, a methyl group with a carbonyl group, is also called an acetyl group, okay? So if this is called an acetyl group, you'll understand why the main component of vinegar is also called acetic acid. So it's acetic acid, and it's also called ethanoic acid. So it actually has two names, the main ingredient in vinegar. Acetic acid and ethanoic acid are the same thing. We look here, look at this. We've got another carboxylic acid here. We got another carboxylic acid here, and another one here. That is citric acid there, and we have lactic acid down here that's found in milk. And also in your muscles when you work out. That's the burning you're feeling in your muscles. Is your acid is actually eating away those muscles so they can build up to be stronger next time, okay? Naming the carboxylic acid is nothing crazy. You'll just notice that it has an oic at the end. That's kind of what we're looking at there. So you're going to be looking at, if this is the C in here, 1C, so we call it meth, and it's methanoic acid. That's all you got to do. This one's got 2 carbons, so we call that ethanoic acid. If it had 3, it would be called propanoic acid. So just make sure that your carboxylic acids end in oic acid. So that'll help you out. Let's look at these two. Here we go. Look, 1, 2, 3. That is propanoic acid, and this is 1, 2, 3, 4, 5. So that's called pentanoic acid. That's just how it looks. It's not too bad. Hopefully you're getting the hang of this by now. All right. Reactions to carboxylic acid. They act like bronzolari acid, which means they donate protons. So imagine if I had this carboxylic acid is methanoic acid. If I had methanoic, well, I don't know if it's methanoic, but because there could be something else over here. But this carboxylic acid here is going to donate a hydrogen to water. That water is going to become the hydronium ion, and then what we're left with is this guy right here. So it becomes, this is the what I would call the conjugate base to this carboxylic acid, okay? So that's how they look right there. They just donate hydrogens, that little hydrogen at the end of that thing right there. If we look at this guy right here, same thing. This is going to donate a hydrogen to that, which is going to produce water, H2O. And then you're going to left with this this O minus here, but of course this K is going to get kicked out because this H goes with this OH, and this K gets kicked out and has a positive charge, which is attracted to this O, which is now has a negative charge because it's missing that bond. So if this looks like it's 1, 2, 3, that's propanoic acid. I don't know what you call this, like potassium propanoate or something like that after this is formed here. If we look at this guy right here, once again, the hydrogen is going to donate or be donated to the ammonia, and you're just going to form ammonium right there, and then you're going to be left with the, looks like 1, 2, 1, 2, 3, 4. That's a methyl group off the side of that. So That'd be off of butanoic acid, kind of deal like that. All right. How to make carboxylic acids. We've already gone through this as a review. You should have this written down already. But when you take a primary alcohol, remember that is when the hydroxide is attached to a carbon and the carbon is only connected to one other carbon or something like that. If you take that primary alcohol and you mix it with some potassium permanganate or potassium dichromate, you go through an aldehyde process and then finally into a carboxylic acid. So anytime you take a primary alcohol, you're eventually going to form an aldehyde and a carboxylic acid right there. So that's how you make carboxylic acids. That's a review from what we went through before. Okay, we're on to esters. 1/3 of the way done here. Here's your ester here. Remember, it's going to have a carbonyl group, and then it's got the OC coming off here. So isopenyl acetate, if you want to do some artificial banana flavoring, I want this to taste like bananas. You'll use that right there. If you want something to taste like strawberries, you got that right there. Methyl cinnamate is, I don't know why it doesn't taste like cinnamon, but it's going to taste like strawberries. And then finally, you've got this one here, methyl anthranilate, which is for grape flavoring. So what you should see is that esters have clearly the things that give us the sweet taste of things that we have. And that's why there's a chocolate company named Ester Price. That's the esters. That's what they're talking about because they taste sweet. So what do you do when you name esters? What you want to look at is which side of the molecule contains the carbonyl group. So is it this side or is it this side? It's this side right here, okay? And that side gets what we call the O8 suffix. So notice there are 2 carbons on this side. The red part has 2 sides. The side that is on the other side of the O is called the alkyl group. So we're going to name this accordingly. We're going to name the alkyl group first, and then we're going to name that right there. So this is just called methyl, and then ethanoate. So methyl, and then ethyl, because it's got that ethanoate, because it's got that whole, the whole ester thing there. Okay, let's try some other ones here. Look at this. So here's the side that has the carbonyl group. So there's only 1 carbon, so that's called methanoate. And then you have this side over here, which is ethyl. So this would be called ethyl methanoate. So ethyl methanoate, right? This guy right here, look at this. Here's the carbonyl group. See, this is the other side. There's 1, 2, 3, 4, 5, 6. So we're looking at hexanoate, and then 1, 2, 3. So we look like we got propyl hexanoate. Yay! That's it. So propyl, and then hexanoate. All right. How do we make esters? Essentially, it is we take a carboxylic acid and we mix it with alcohol right there. We take it with an alcohol, and what happens here is that the H from the carboxylic acid does its little Bronsted-Lowry base thing and donates a hydrogen over here to this alcohol. That alcohol will now form water right here. That's the things that are circled. And then what's left over, of course, is that hydrogen's gone, and here's our R, which could be a carbon or whatever we got. And now what you've got is you've got a carboxylic acid formed and water. So here you go. That's called the Fischer esterification. There you go. And look what I have here. These are called ester eggs. Whoo, boy. All right, let's see what we got. We're on amides. I'm going to call them amides for now on. That's it. I'm making a decision. All right, we look at these guys right here. You've seen these before. You got acetaminophen. You might hear that as Tylenol or anything like that. That's the competitor with ibuprofen. They're not the same chemical. Some of them are good in certain situations. Some of them are not good in other situations. So this is acetaminophen. You'll notice that it's an amide. If you look at what it looks like, it's got the NH. There's the amine group connected to a carbonyl group. All right. So you're always going to see something like that. So here's a carbonyl group here, right? And there's an amine. So carbonyl group there. So this is caffeine right here. You'll see that on people's T-shirts that are hilarious. Chemistry people that are really into coffee. You'll see that. That's caffeine. And then down here you got ampicillin. You're like, what is that? Well, it's an antibiotic. It's like penicillin, but it's just a little different. And we're constantly messing with this ampicillin or anything like that to make sure that it can the bacteria get food and they latch onto this instead of our cells. It's a beautiful thing. So this kind of will kill them. All right, let's keep going. When we name them amides, let me show you how to name these things. It's nothing crazy. Look at this. We've got one carbon, so that's called methylamide right here. 2 carbons, ethanamide, and then 3 carbons, propanamide. So see if you can name these before I give you the reveal. Let's see, we got 1, 2, 3, 4. Butanamide. There you go. And then 1, 2, 3, 4, 5. Let me move my picture out. Here you go. That's pentanamide. So 1, 2, 3, 4, 5. So I don't know if I might call that pentanamide. I don't know. We'll see. Okay, this might be butanamide. Okay, let's keep going. Amino acids. This is a little bonus for you here. Like you'll notice that an amino acid has an amine group, and it's got a carboxylic acid group. So that's why they're called amino acids. That's why they're called that. These are the building blocks of proteins. You've seen different types like glycine and methionine and tyrosine and tryptophan and phenylalanine. All those are your amino acids that make up all the proteins in your body. And then if we look here, there are 2 different types of forms. There's a regular form that we always write them out as, but there's also something called a Switter-ionic form. And what that does is it kind of removes this hydrogen and puts it over here, which creates a positive and a negative end of our amino acid. I'm going to show you on the next slide why that would happen. So think about this hydrogen is over here now. Now that means that nitrogen's got 4 bonds where it should only have 3, which is why it's got that positive charge. And then that oxygen only has 1 bond where it should have 2, which is why it has the negative. So there you go. So let's show you why we have that as well. Let me see here. I'll keep it right here. You guys can read that right. Boom. So what we look at here is there's the Zwitter-ionic form of this amino acid and the Zwitter-ionic form of this amino acid. And what's going to happen here is this these hydrogens and these oxygens are going to combine. Let me show you how they look. There's a hydrogen, there's an oxygen right there. Oop, H2O, you're going to form water right here. And then what's going to happen is that's going to leave this carbon missing a bond here. So, and since it misses a bond here and this nitrogen wants a nice little bond there, you are going to combine them and make a longer thing. So this is the dehydration part of it. It's removing water. And you're also synthesizing a much larger compound. So it's called dehydration synthesis. And that's how we make our proteins. We just take amino acids and keep linking these link them together. And those are through peptide bonds. And here's what they look like. So if you had amino acids here, everything in here, they call them amide bonds, but we call them peptide bonds in biology class. So that's what we're looking at, okay? I can't click anymore, which means we're done. And guys, let me put this back down here just to end the program. Boom. That is Unit 9. Best of luck to you. Please ask me questions if you need them. And I'll see you guys as soon as I possibly can. All right? Have a good rest of your day.